Now we will solve the section P of problem 3.8, Griffith 4th edition Introduction to Electrodynamics. The section P is find the induced surface charge on the sphere as a function of theta. Integrate this to get the total induced charge. So in section A we have seen V of r and theta is equal to q divided by 4 pi epsilon naught multiplied by 1 over square root r squared plus a squared minus 2 r a cos theta minus 1 over square root of here you can see capital R squared plus a r small r over capital R whole square minus 2 RA cos theta. Now what is sigma? Sigma is equal to minus epsilon naught delta V over delta N, where N is the nth direction. If direction is R, then sigma can be written as minus epsilon naught delta V over delta R. This comes from the Gauss law. Gauss law says E is equal to, we know, for two dimension surface area sigma over epsilon naught. But what is E? Electric field is negative gradient of potential, that is minus delta V over delta R. So if you bring this epsilon naught here, sigma will be equal to minus epsilon naught delta V over delta R. That's what I have written here. Now we have to differentiate this potential. This can be, we can split this conveniently into two parts. The first 1 over square root term you can keep as A. Then second one as P, in order to make simplification, mathematical simplification. And later on we will multiply by Q by 4 pi epsilon naught. First you differentiate this. This can be written as this square root term as minus of power minus of. It will go to numerator, it will be power minus of. If you differentiate this, you will get minus 1 over 2 the terms inside the square root power minus 3 by 2, because you are differentiating. Now you differentiate this again with respect to r. This r squared will become 2r. This a squared will be 0. Then this 2r, if you differentiate that term with respect to r, you will get 2a cos theta. Now you substitute that boundary condition, that is, this is at capital R, at the surface of the sphere. So that means you have to replace r small r by capital R. So this will become capital R squared plus a squared minus 2 capital R a cos theta power minus 3 by 2. This will become capital R 2 capital R minus 2a cos theta. In similar way, we will find out delta P over delta R. In a similar way, we got delta P over delta R is equal to half R squared, capital R squared plus a small r over capital R whole squared minus 2 RA cos theta. This is the denominator in this second term, which is a square root of this one. If you differentiate this, you will get minus of and power minus 3 by 2. Then you again differentiate this with respect to r. First term will be 0. What about second term? Second term, if you expand, you will get a squared r squared over capital R squared. If you differentiate this r squared, you will get 2r. Then you got 2r and this a squared over r squared. And if you differentiate the third term, you will get differentiate r with r is 1. So this will become 2a cos theta. At the boundary, delta p over delta r at boundary capital R is equal to, you replace small r by capital R. First term you will come as it is. Second term capital R divided by capital R is 1. So this will become simply A square. This will become minus 2 capital R A cos theta power minus 3 by 2. Here, if you convert this R into capital R, then this R squared will get cancelled with this R. Then this will become 2A squared over R. So minus, of course, minus 2A cos theta. If you differentiate the third term, here there is no small r, so you keep that as it is. We have already found that uh, delta A over delta R is equal to this one. So both under the boundary condition. Now if you subtract this from this, you have this as a common factor minus of this 3 by power minus 3 by 2. It's a common factor. You take it as a common. Then this minus this. So here you have 2r minus 2a cos theta, and here you have minus 2a squared over r here, and this minus of minus will become plus. This become minus, this will become minus of minus plus 2a cos theta. Now this plus 2a cos theta will get cancelled with this plus 2a cos theta. Then you can see here you have 2. This 2 will get cancelled with this 2. Here you have 1 2, and here you have 1 2. Now r minus a squared r squared. Now we will simplify this. That is, you have r minus a squared over r. You take r as a common factor, then this first term will become r squared minus small r a squared. So this can be written as r squared minus a squared. I am bringing this 1 over r in front. So we got minus 1 over r capital R squared plus a squared minus 2 capital R a cos theta power minus 3 by 2. Then after simplification of these terms inside the bracket, we will get r squared minus a squared. So we will simply, this is the delta V over delta R. Now sigma is equal to minus epsilon naught delta V over delta R. In delta V over delta R, we got one negative side. This is minus 1 over R, and all these terms. So minus of minus will become plus. So you can write simply as Q over 4 pi epsilon naught. This delta V over delta R is epsilon naught 1 over R, and all these terms. Now, what is the induced charge? Induced charge can be written as integral sigma TA. TA is small area element, TA, which is equal to capital R squared sine theta t theta t pi. So, if you differentiate with respect to pi, you will get 2 pi. So now you can take 2 pi is a constant outside. Then r squared also, capital R squared also a constant. So you can take 2 pi r squared constant outside and integrate with respect to sigma sine theta t theta. That is, you have to differentiate with respect to t theta. Now you substitute this sigma you got it here, and you substitute it here in the integral. Then you will get already q over 4 pi. Here this epsilon naught will get cancelled. So you will get q by 4 pi, and this 1 over r. Here you have 2 pi r squared multiplied by this factor. This is also independent of theta. So that we can take out r squared minus a squared. Then remaining term r squared plus a squared minus 2 capital R a cos theta power minus 3 by 2. You are integrating with respect to theta between the limit 0 to pi. Now let us take this as u. This as u. the terms inside the bracket is u. That is u is equal to capital R squared plus a squared minus 2 RA cos theta. If you differentiate this with respect to theta, then this tu will become first two term independent of theta, it will become 0. If you differentiate this cos theta, will become minus sin theta. So minus of minus will become plus 2 RA sin theta t theta. Then what is t theta? Here you have t. So t theta is equal to, you bring other thing to the left side. T theta is equal to, I think I can write here instead of writing here. This u also I will take out. So this t theta can be written as, you bring 2RA to the other side, tu over 2RA sin theta, 2RA sin theta. Here this sin theta and this sin theta will get cancelled. This sin theta and this sin theta. So you can replace this t theta as tu 1 over 2 RA. I have taken 1 over 2 RA outside. Tu only I kept inside. This is u power minus 3 by 2. Now I have to change the limit also. What will happen if theta equal to 0? Cos 0 is 1. So this will become r squared, lower limit. For lower limit, this will become 1. Cos theta will be 1. So this will become r squared plus a squared minus 2RA. What about upper limit? Cos pi is minus 1. So this will become plus. So this will be r squared plus a squared plus 2RA. So upper limit is this one and lower limit. And you have to integrate u power minus 3 by 2 with respect to tu. Now you can see this r will get cancelled here. This r will get cancelled. Here you have 2 into 2a, 4a. So you will get q by 4a r squared minus a squared and this integral. Now we will carry out this integral. So now we have to integrate this in order to get induced charge. If you integrate u power minus 3 by 2 with respect to u, you will get minus 2 u power minus half. So this 2 will get cancelled. 4 cancelled with 4, you will get 2a. Then you have the here negative sign. Then first you apply the upper limit. That is, this is u power minus half is 1 over square root u. So which is equal to 1 over square root of this upper limit. Capital R squared plus a squared plus 2RA. Then minus the lower limit 1 over square root of r squared a squared minus 2RA. Then you can see the first denominator. First denominator can be written as r plus a whole squared. R plus a whole squared is equal to r squared plus a squared plus 2RA. If you take square root of this, this will become simply r plus a. For mathematical reason, I am writing this as a plus r. I will explain it why. In the second denominator, you will get square root of, this is r minus a squared. R minus a squared. R minus a squared, what is r minus a squared? R squared plus a squared minus 2RAP. Same thing, if you take a minus r whole squared, what will happen? A minus r whole squared. That is also a squared plus r squared minus 2RP. So there is no difference. R minus a whole squared is equal to a minus r whole squared. Here only thing is we know the outside the sphere, A must be greater than R. So A is a larger number. So that is the reason why instead of writing A minus R minus A whole square, I am writing A minus R whole square. Both are same. So if you expand, you will get same result. So I am writing this as, if you take square root of A minus R whole square, you will get A minus R. So now you can take this minus q over 2a r squared minus a squared. This I am taking as common, a plus r into a minus r. In the denominator you will get numerator, this is a minus r and minus a plus r. Here if you see, this a will get cancelled, plus, and here you have minus r, minus r, so minus 2r you will get, minus 2r. So you will get minus 2r divided by the denominator, a plus b into a minus b is equal to a squared minus r squared. You know, a squared minus r squared. Uh, but here this minus will become plus. Remember that here you have r squared minus a squared, here a squared minus r squared. So I can change the denominator by or numerator by a squared minus r squared. That means I have to multiply by minus. This can be written as minus a squared minus r squared. That means this will become, if minus goes to inside, then r squared become plus r squared minus a squared. Now you can cancel this a squared over minus r squared and a squared over minus r squared. So you will get only the negative sign, negative, and here you have r. Of course, this will get cancelled. This only we have rewritten as minus a squared minus r squared. So both will get cancelled. In the numerator, you have r divided by a. Of course, minus r divided by a into q. This is exactly what is q prime. We have seen in our example 3.2. So this is induced charge. You can verify this from our example 3.2. Then we will see part C. Thank you very much for watching my videos and supporting me continuously. Thank you very much.